So what I did was I opened this document up in Safari. Then I went to the markup, saved it as a PDF, and that's what I'm looking at here, so that I can have that markup option. So here's the markup button. I can select my utensil and color. So for example, red or blue. And then I can do things like I can label this thing right here, for example. So I want a pencil. I want it to be red. This is going to be the tRNA. tRNA just stands for transfer RNA. This down here in the green, the UUC, that's the messenger RNA. So that's copied the DNA and now has moved to the ribosome where we can make proteins. Those three letters, UUC, that's the codon. And then the AUG, that's the anti-codon. And then this blue right here, that's going to be the amino acid. All right, so that gives me kind of an idea of what some of those things are. Now I'm going to scroll down here to look at some of these answers. So in reading the codon chart, unless otherwise specified, generally, so I'm going back to my markup here so I can use my pen. Generally, I'm going to be using the messenger RNA codon. So where it said UUC, that's what I'm going to look up here to find out what this amino acid is. That's in blue. The codon chart demonstrates that more than one codon can potentially code for the same amino acid, and that's true. Look, valine, 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 valine. More than one codon for that same amino acid. So I'm going to say that's true. The information in this rectangular codon chart can be represented in a different way, and that's also true. So sometimes it's in a circle, sometimes it's in this rectangle, either way. How many different combinations are shown on this codon chart, and how many different types of amino acids are shown on this codon chart? Well, that's going to require some counting. So we know that there's only 20 amino acids, so we can get that pretty easy. How many different combinations? Again, you're just going to be counting. You've got 4 on the one side, 4 on the other side, 4 on the other side, so you're doing some multiplication there. All right, so from the video, if I have the messenger RNA codon, AUG, that's what I'm going to be looking up here. I go to the A first, then I go over to the U second, and then finally I go down here to the G, and where those intersect, so it's going to be this box is the row I'm looking at. It's the U column down here to the G, and we're just going to abbreviate it with the letters MET. And so that's what they've done here in this example. All right, so if I have the messenger RNA CCA, well, what pairs with C? G, what pairs with C? G, and then there is no T in RNA, so GGU. For the amino acid, I'm going back to the chart and I'm going to look up CCA. So I start at C, that's number 1. This other C is number 2. And then down here, A is number 3. And that's going to give me proline. So I'm just going to abbreviate that PRO. P-R-O. All right, then I go to example 3 from the video. GUC. Well, it's going to pair with C, A, G. But I'm looking up GUC for the amino acid. So GUC, so I go back up here. I'm going to go to G first, G, then U second, and then down to C third, and that's valine, V-A-L. So I'm just going to write that here in the amino acid place, V-A-L. All right, now I've got a codon chart here, and it's going to ask me a bunch of questions about it. So the 6 messenger RNA codons for leucine, I'm going to find leucine right here, and I'm just writing out what those things are. So first U, second U, third A. First U, second U, third G. See how like A and G, A and G? Then first C, second U, then third U, C, U, C, C, U, A, C, U, whoops, that should be a C, U, G. All right, just like that. So what I'm doing is turning off the markup so that I can scroll up and down, and that helps me mark up this PDF document. What will be the 6 tRNA anticodons? All right, so this is on messenger RNA. So if I scroll back up here, again, I'm looking at messenger RNA. That's this right here. The tRNA anticodon is this right here. All right, so that's what I'm looking for. What pairs with those letters? So what pairs with U? A, U, because there's no T's. Then I'm going this UUG. It's going to be AAC, G, U's pair with A's, G, A, G, G, A, U, G, A, that should be a C. All right, now for the DNA. Now for DNA, I've got to reintroduce the T. And I'm not basing it on this. I'm basing it on this. It's because messenger RNA is what copies DNA. All right, so I've got to base it on that. That's why I've got an A pairing up with those U's, but now I'm introducing the T again. All right, so if I've got a U up here, it's going to be AAC, and then it's going to be GAA, and then it's going to be GAG, GAT, GAC. All right, like that. All right, true or false? Changing one base letter in messenger will always change. That's false. Because sometimes, like leucine, I could change one letter and still get leucine. The messenger RNA codon GCU and GCC would share the same tRNA anticodon. All right, well, that's not true. It'll share a different anticodon, but it might code for the same amino acid. All right, which is what 16 and 17 are dealing with. Number 20, stop codons can signal the end of a polypeptide. That's just the end of the protein chain. What are the 3 stop codons? So I'm just looking up here in my chart to find these 3 stop codons. Stop, stop, stop. And I just find the letters for those. U, A, U, A, G, U, G, A. For those stop codons. AUG is generally a start codon. What does that code for? So I'll just find AUG up here. So A is going to be my first one. So again, I'm at A for the first one, U for the second one, and then G for the third one. So MET is generally going to be my start codon, the code that I need to get things started. MET. Nice highlighter there to write with. All right. So that should help you out with filling out the tRNA chart.